In fact, their distance to 4.4.4.4 is the same. AD on the top is less than FD. The AD on the lower side is also smaller than the FD on the upper side. There is no problem. So let's first look at the bandwidth and latency of R2. Let's take a screenshot of it. This is the bandwidth and latency of the R2 write interface. Then we make a modification. We modified it on R3. Then I must go to the interface of R3 first. The right side of R3 is the S11 interface. After coming in, we are going to change the bandwidth. This value can be changed directly. We can enter a question mark to see. Okay. We can now directly change. Then just enter the value here. Change to 10,000. After changing, there is a delay here. Type a question mark after the delay. Let me emphasize. There is a tens written here. Is that it will multiply by 10 by default. So, if you want to change the delay here to 1000, then you can write a 100 here. If you write 1000, here it becomes 10,000. Because it will multiply by 10 by default. In some configuration parameters of many networks have similar concepts. So sometimes you need to pay attention. Let's just change it to 100 right here. Let's take a look when we're done. Show interface S11. Now we see this interface. It seems to be the same as before. Now the bandwidth is 10,000. The delay is also 1000. It is equivalent to changing the parameters of these two interfaces to be the same. If you look at the IP header later, in fact, there is a parameter in it that will be multiplied by default. That's not the point. Now these two interfaces, I changed it to the same. So let's look at the topology table on R1 now. See if there will be a change. Show IPEIGRP topology. Okay. Now let's look at the topology table. There are two lines in it. Because now the main line and the backup line, the two values become exactly the same. This can also be brought into the formula just now to calculate. At the beginning, it should be more than 2.29 million. Now it has been changed to more than 400,000. It's smaller than this 430,000. So it comes in now. The topology table does not add all links. It has appeared now. So when this comes up, let's check the IP routing table again. Now R1 goes to 4.4.4.4. First of all, let me take a look at the topological table. Check out all links. For now, the same goes for all links. So why doesn't it appear in the routing table? Let me check. In the routing table this is 4.4.4.4 going to 4.0.0.0. The second item of the next hop does not appear. It should be advertised that the distance is also equivalent. There is a problem with the configuration just now. Let's check the configuration just now. Show IP router. This is the topology table. Both of them are already in the topology table. The next hop is the serial interface. Okay. We should not look at the routing table. There is now only one entry in the routing table. Let's look at the topology table and it's okay. It now appears in the topology table. Well, the experiment is actually over. Everyone can demonstrate. I leave you with a thought question. For example, down the interface above. Then you can look at. I give a simple example. You can refer to it after class. I am now going to ping this 4.4.4.4 from R1. Suffix a repeat. After that, I down the above interface. Then let's take a look. When can it switch to the link below? That is to say, now through our artificial modification, the route below has become an alternate path. Because we already have it in the topology table. Let's ping it first. I teach you a command. For Cisco inside. It does not have a command called ping all the time. It must be suffixed with repeat. For example, I'm going to ping 4.4.4.4 now. It works. Then we will add a command like this later. How many suffixes do you want it to ping? Suppose we ping 10,000 times. Then we are in the process of ping. Let's advance to the R2 interface later. Left port of R2. E00. Let's shut it down later. Okay. We enter this interface. Interface E00. Then shut down. After the shutdown is completed, let's ping here first. Then see how many packets it drops. Then switch back. We start ping. Shut down. Let's observe. It drops a packet. Dropped 2 packets. Dropped 3 packets. Actually, it does not realize the real second machine switching. This is actually due to the problem of the current simulator. It is still different from the real machine. Okay. Press Ctrl+6 to turn it off. So now everyone can see. This link is actually down. Because this interface is actually down. After down, it is indeed switched now. But it does drop packets in the middle. About 6 packets were dropped in the middle. That actually puts it in the job. EIGRP is slightly faster than in the simulator. Relatively speaking, the presentation is a bit slow now. That is, these exclamation points above. In fact, it means that the line is going up. Then when the interface is down, after a discarded packet is generated in the middle, its line quickly switched to the bottom. Everyone can observe the experimental phenomenon after class. Before you turn the link below into a backup line. Then do this. See how many packets are dropped in between. After that, you can follow what we said in today's class. Make it into a feasible successor router. That is R3. You turn it into an alternate line. Then you go down the interface of the above line. Observe how many packets are dropped. About 3 times that. Takes about this long. It needs to be recalculated when the packet is lost. I won't demonstrate in class. EIGRP is actually almost so much content. Finally, let me emphasize. After we artificially modified, we can take the original suboptimal path. Become a backup path. In order to achieve second-level switching. Keep business uninterrupted. Actually, the real chance is slightly faster than the simulator. And our modified delay. The one we modified is called the logical attribute. It is not a real physical property. That is, the bandwidth is actually generated according to the physical characteristics of the interface. You change an F port to 1000. It's not a gigabit port either. It's just that the command we wrote, only when calculating based on routing, will serve as a logical reference parameter, which then affects our calculations, which in turn affects routing. We talk less in the NA stage, because the overall dual algorithm will be covered in the NP phase. So these parameters mentioned in NA, you also need to understand the name. Next,